All right, take out those packets and let's start writing down some information about reflections, okay? So a flip over a line called the line of reflect is called the line of reflection. Each point, its image are the same distance from the line of reflection. And a reflection is also an example of a rigid motion. Who can remember, what does rigid motion mean? What do we remember about rigid motion? We kind of talked about that yesterday. It was like one of the definitions we did. What is always preserved with a rigid motion? I put two on there, didn't I? Hold on. They're not up there actually. Sorry about that. What's rigid motion? Because that's really important to know. What's rigid motion? Yeah. Yeah, when it preserves that size and that shape, that means all sides are congruent, all angles are congruent, which means all we're doing is we're taking the shape and we're just moving it in a different direction in the coordinate plane. We're not doing anything else with it, okay? So some common lines of reflection are the x-axis or the y-axis. You have a vertical or horizontal line in the form of x equals a number or y equals a number. And we have diagonal lines. So for example, you can have y equals x and y equals negative x. Show of hands, who's still writing this down? Okay. Okay, so let's bring this over. All right, so it says graph and label each point, each figure and its image under a reflection in the given line. Give the coordinate to the image. So what I want you guys to do is I want you to just plot the original shapes. I'll give you a few minutes to do that. And then we'll talk about these reflections, okay? Just plot the original shapes. Okay, so let's talk about these a little bit. I'm sorry, who's still plotting those four shapes? Anybody? All right. So let's take a look at this first one. So if I have this triangle A, -4, 1, 2, 3, 4, and then up 2, there's my A. B is 4, 1, 2, 3, 4, and then up to 7. And then 5, 1, 1, 2, 3, 4, 5, and then up 1. Okay, so here's A, here's B, here's C. Okay, and I'm just going to connect these. Now they're telling me that we're talking about a reflection over y equals 0. Y equals 0 is right here. Oh, I'm sorry. Nope, it's not. That's x equals 0. Sorry. Y equals 0 is right here. And this is our x-axis. So when they're asking us to do a reflection from here, there's an actual rule for this. And if we look right here, I wrote it down. The point xy is basically getting a negative y in the end. So if I want to label these points my A prime, I'm looking at this and I'm just going to switch the y to a negative. So this will be -4, -2. My B prime would be 4, -7. And my C prime would be 5, -1. And that's what I'm going to graph here. So 4 negative, just to see if it works. So 1, 2, 3, 4, down 2. There's my A prime. 4, 7. 1, 2, 3, 4, all the way down to 7. There's my B prime. And my C prime is 5, 5, and then to -1. So here's A prime, B prime, C prime. Now, how can you check to make sure you did all this? It should be equidistant from the line of reflection, okay? So if you look, we have 2 spaces to the line of reflection here. We have 2 spaces here. For B, we have 7 spaces. Here we have 7 spaces. For C, we have pretty much 1 space, and we have 1 space. So that is a legitimate line of reflection. Okay? Now we're going to do the same thing for this rectangle. Now, you plotted everything. Let's just go straight into what we needed to do here. So now this is a reflection about x equals 0. So here's x equals 0. And that's telling me that all the x's get changed. So in this case, I'm going to have, for P, -1, 2. For Q, I'm going to have -2, 5. For R, I'm going to have -8, 3. And for S, I'm going to have -7, 0. So when I plot this, I'm just gonna plot it real quick just to kind of show you guys. So we have -1 up to 2, -2 up to 5, 5. So here's P prime, Q prime. R is -8 up 3, and S is -7, 0. So that should be what your reflection looks like. I want you guys to try it for 3 and 4 on your own. Make sure you take a look at what the R, like what you're reflecting, okay? Go ahead. Okay, so looking at this, just remember that K is right here. K prime is right there. It's equidistant from that line. L and L prime equidistant from that line of reflection, and J prime, same thing over here. So each point is equidistant from the line of reflection, and we're working on these two. Okay, guys, you're still working on these two? Okay, so again, let's make this equidistant from this line of refraction. So D, I'm going to, is a distance of 2. There's my D prime. E is a distance of 1. There's my E prime. F is, looks like 1, 2, 3, 4, 5 spots away. So 1, 2, 3, 4, 5. Here is my F prime. C is 1, 2, 3, 4, 5, 6 spots away. So here is my C prime. And then I connect. Okay. Now I'm just going to show you number 8 just to make things a little bit easier. Just remember, everything is supposed to be equidistant. So here it is. And if you look right here, this was your line of reflection right there. And these are all the points. Questions on this? Yeah, I'm just going to double check something. I don't think you guys need to worry about the angles of reflections. And that is it for you guys. All right, so you do not need to worry about anything down here with 9 or 10 or 11 or 12. We will talk about this tomorrow. So what I want you guys to do is you're going to have the following for homework. You're definitely going to have 1, you can cross out 2. You're going to have 3 and 4. You're going to have 5 and you're going to cross out 6. You guys don't need 6. You're going to have 7, cross out 8. And we'll talk about the rest tomorrow, I think. Okay. But anything that says y equals x or y equals negative x, do not worry about those problems, okay? And we'll talk about the lines of reflection tomorrow. And that's it. Those of you watching, have a great day.